Welcome to Sequences and Series Part 2, brought to you by Martin Tutorials, and we continue learning about the Algebraic Series. A quick reminder, I have two YouTubes, Variety and Fun Math and Martin Tutorials. You're encouraged to subscribe to both. Today's lesson will be sent to both those YouTubes, and really important, today is a continuation of Part 1, Sequences and Series. Everything in today's lesson is based on Part 1 and that you've watched Part 1. If you haven't watched Part 1, please do. It's on both my YouTubes. It's actually all one lesson. I just broke it up into smaller chunks so it's easier to learn small bits at a time. But today is directly based on Part 1. Let us begin. I have in front of us an algebraic series based on what we learned, because each term increases by the same amount. We're adding on 2 between each term. I have two questions. I say one is a fair question, the other is an unfair question based on Part 1 of this YouTube. The fair question is T3 because we did learn about it. The unfair one is S3 because we haven't learned about it. Well, I'm going to be unfair then. Does anyone know what T3 equals? And why? T3 equals 9. Do you know why? Because T3 says what is term number 3. Term number 1 is 5, term number 2 is 7, term number 3 is 9. Now what is S3? I haven't taught it yet. I'll give the answer, but that still doesn't explain where I got it from. S3 equals 21. Why? Because S refers to the sum of the first 3 terms. 5 plus 7 plus 9 equals 21. You got it? So like T2 is 7, S2 is 5 plus 7. So that's what S refers to, the sum of the terms. And of course, a reminder, terminology might vary between courses. If your teacher uses different terms, obviously use what your teacher suggests. Unfortunately, I cannot do what every teacher wants because I can only do it one way here, but always use your teacher's terminology. All right, so we already learned a formula to find the nth term. What I'm going to do now, that's the formula. The nth term is a plus n minus 1 times d. I taught in the previous lesson. Now I'm going to do is derive a formula for the s term, the sum of the terms. We learned in part 1 of this YouTube that the terms of a series is a plus d plus a plus 2d. All the way up, the last term would be a plus n minus 1d. Remember, term number n is a plus n minus 1 times d. And if we want to put the previous term, remember, each term goes up by d. This will be d less. That's n minus 1 lots of d. That's n minus 2 lots of d because it's d1, d less than that. And that's the term number. Term 1 is a. Term 2 is a plus d, etc. What I'm going to do now is rewrite it, but in reverse order. I'm putting term a here, a plus d, etc., all the way until a plus n minus 1d. That's the sum of all the n terms, is adding them up, and it'll get the same answer if I reverse the order. And what I'm going to do now is add each column. If that's sum of the terms, that's 2 times sum of the terms, despite my handwriting. If I add this up, a plus n minus 1d would give me 2a plus n minus 1d. If I add these two terms, there's 2a, n minus 2 lots of d plus 1d would give me n minus 1 lots of d. Do you notice we get the same answer? And let's go to the last one. We add the terms. A plus a is 2a, n minus 1 lots of d. It stays the same. We get the same answer each time. And that's not surprising. If I go across, one term goes up by 1 and one term goes up by a certain amount, the other one goes down by the certain amount, we add them, we'll get the same. It's like if 7 plus 5 is 12, one number goes up by a certain amount, the other one goes down by a certain amount, added together will stay the same, because the amount up and the amount down added together gets the same. Okay, this term went up by a certain amount, this one went down by a certain amount, so adding them will get the same answer. So here I have lots of 2a's plus n minus 1d. And what's a quicker way of saying lots of? If I had 7 lots of them, I would say 7 times this. If I've got n lots, because remember there's n's the number, 1, term 2, term 3, all the way until term n. So instead of writing it out 10 times, I just say n lots of 2a plus n minus 1d. So remember there's 2 lots of the sum of the terms is n times 2a plus n minus 1d. It's an equal sign. I divide each side by 2. The sum of all the terms is n over 2 times open brackets 2a plus n minus 1d. Or you can write it all over 2. It's 2 different ways of writing the same thing depending on your teacher. That's the formula for the sum of n terms. That's the formula for finding the nth term. What is term number 4? What is term number 7? This is the formula for adding up the terms. What do the first n terms add up to? Now I'm going to do one little manipulation. Instead of saying 2a, I'm going to write it as a plus a. Here we've got a plus n minus 1 times d. We already see here a plus n minus 1 times d is another way of saying tn, the nth term. So instead of saying a plus n minus 1d, I can replace it with tn. So that's another formula to get the same thing. The sum of all the terms is n over 2 times 2a plus n minus 1 times d, or it's n over 2 times a plus 2n, tn. Okay, both those formula gets you the right answer depending what information you're given. If they tell you tn and a, you might use this formula. If they tell you d but not tn, you might use that formula. And another way of writing it is putting it all over to. It's just 2 ways of saying the same thing. And just think of it. It's the average of all the terms times n. There's n lots of them. The average is the first plus the last term divided by 2. That's the average for all the terms times n. Okay, so that's our 2 formulas. So what I'm going to do here, I've got a question I made up. We have an algebraic series, 3 plus 7 plus 11 plus 15 plus 19. What is the 50th term? What do the first 50 terms add up to? We learned this formula before in lesson 1 of a plus n minus 1d, 3 plus 50 minus 1 times 4, because I realized d equals 4. And I do the arithmetic, 49 times 4, I multiply it all out, I get 199. The next question is, what is the 50th term? And that's the formula we just looked at a second ago. It's 50 over 2, 2a is 2 times 3 is 6, the first term is 3. The 50th term, 50 minus 1 times 4, and we keep simplifying. 50 divided by 2 is 25, 50 minus 1 is 49, 49 times 4 plus 6, 202. Multiply that out, or use a calculator, I get 5,050. So that's term number 50. If we had to write this out 50 terms, we'll discover the 50th term is 199, and we add up all the terms, we'll get 5,050. And now one other question that I made up. Here's another sequence, 7 plus 10 plus 13, dot, dot, dot. The last term is 100. Add up all the terms. So this question is similar to the previous, except other information is given. Here they tell us how many terms, but they don't tell us what the last term is. Here they tell us the final term, but they don't tell us how many terms there are. So it's the same question, but different information given. I think to solve it, first of all, I want to find out how many terms. We have this formula that the nth term is a plus n minus 1d. We don't know what the nth is, but that last term is 100. A is 7, D is 3. We can use this now to work out what n is. There's a certain n, and term number n, that will give us 100. And now we simplify. We subtract 7 from each side. 93 is 9 minus 1 times 3. We divide each side by 3 because it's an equal sign. 31 equals n minus 1. It's an equal sign, so we add on 1 to each side. N equals 32. Now we can use the other formula. We know n is 32. The other formula gave is n over 2 times a plus 2n. Remember I said there's more than one formula to add up the terms. We know n is 32. 32 divided by 2. First term is 7. The last term is 100. And now we simplify. 32 divided by 2 is 16. 100 plus 7 is 107. We multiplied out 1,712. And that's our lesson today relating to the algebraic series. Thank you for watching. Now you know why I went into mathematics and not art. I'm not a born artist. We agree on that. Talk to you all soon.